Anyways, let us continue. In the last lecture, where did we stop, everyone? Where did we stop in the last lecture? Yes, Kirtini, Sarjana, Bhuvanashri. Last lecture, where did we stop? Yeah, we were studying about, if I'm not wrong, we were studying about sulfur dioxide. We were studying about sulfur dioxide. Yeah, sulfur dioxide, it acts as a reducing agent. This is what we had studied in the last lecture. This is where we had stopped. Yeah, so sulfur dioxide act as a reducing agent. Everyone, what is a reducing agent? Yes, Ragul, Prashanti, Sarjana, Kirtini. What is a reducing agent? Yeah, what is a reducing agent? What do we mean by reducing agent? Reducing agent, what do we mean by reducing agent? Correct. It undergoes oxidation and reduces the other substance. It undergoes oxidation and reduces the other substance. Yeah, that is nothing but your reducing agent. Correct. For example, over here written potassium dichromate. Yeah, what is potassium dichromate? Come on in the chat box. What molecule is potassium dichromate? Prashanti, Sarjana, Kirtini, Ragul. What molecule is potassium dichromate? Yeah. What is potassium dichromate? What is potassium dichromate, everyone? What do we mean by potassium dichromate? Yeah. What is potassium dichromate? No one knows? Come on. K2CrO7, is it? Check in your book. Check in your book. Sarjana, what is potassium dichromate? Ragul, what is potassium dichromate? Yes, Gopinath, Kirtini, what is potassium dichromate? Yeah. What do we mean by potassium dichromate? It is K2Cr2O7. So K2Cr2O7, if I react with sulfur dioxide, you have to remember it like this. If I react with sulfur dioxide, your K2Cr2O7 is gives you K2Cr2O7 is converted into your chromium sulfate, that is Cr2SO4 thrice. So what is the oxidation state of chromium over here? Come on, everyone. What is the oxidation state of chromium over here? Come on, calculate. K2Cr2O7, the single chromium. I want the oxidation state of single chromium. What is the oxidation state of single chromium over there? Yes, Ragul, Kirtini, Sarjana. What is the oxidation state of single chromium over there? Come on, calculate, Ragul. Prashanti, calculate. Kirtini, calculate. Sarjana, calculate for chromium also over here. Like, what will be the oxidation state of chromium over here? Yes, Prashanti, what will be the oxidation state of Cr in K2Cr2O7? Yes, Kirtini, what did you get it? If you have not got it, please tell me. I'll explain you how to solve it. Do not keep it with yourself. I'm not going to shout at you if you say you do not know. Okay? Get your doubts clear. Do not keep it unclear. Yes, K2Cr2O7, the oxidation state of Cr over there. How to calculate? Look over here. K, it is in the group 1. So I will consider it as an oxidation state. What is the charge on K? Is +1. So how many K I have? I have 2K. So +2 plus I am calculating it for chromium Prashanti. So I'll take it as X. So how many chromium do I have? I have 2 chromium, so I'll take it as 2x. What is the charge on oxygen, everyone? Single oxygen, Ragul, single oxygen, Kirtini, what is the charge? It is -2. So -2 into 7, that is -14 is equal to 0. Correct? So if I solve this, 2 plus 2x minus 14, if goes that side, becomes plus 14. X is equal to what? 14 minus 2 is 12. 12 divided by 2, Sarjna, what are we getting? How it is 3? How did you get 3, Sarjna? It is plus 6. What mistake did you do? Okay, is it clear, everyone? So single chromium is plus 6. Single chromium is plus 6. And what is the oxidation state of chromium over here? Can anyone tell me? Prashanti, what is the oxidation state of chromium? Kirtini, Bhuvnashri, what will be the oxidation state of chromium in Cr2SO4 thrice? Yeah? Plus 12. Prashanti, what is the meaning of oxidation state? Oxidation state means the charge on that molecule or the charge on that atom. Okay. Can any atom, can any element go up to plus 12? Is it even possible? Did you ever see charge plus 12? We have seen plus 2, plus 3, plus 1, plus 12. What? Acha, right hand side chromium. Good save, good save. Okay. See, you do not have to calculate it for the Cr2SO4 thrice. SO4 is -2. It is like an ionic compound, Prashanti. You do not have to calculate with taking X. Okay. So you have chromium 2 SO4 thrice. So if I dissociate this, Prashanti, it will go like this, no? Cr, how many Cr I have? I have 2 Cr and 3 is the charge. I'll write it over here, wait. So I have Cr2SO4 thrice. Cr2SO4 thrice, correct? So Cr plus 3, okay, 2 will go on SO4, SO4 minus 2. How many Cr I have? I have 2 Cr, I have 3 SO4. Correct? So what is the charge on chromium? The charge is plus 3. Okay, so plus 6 to plus 3. Is it oxidation or reduction? Plus 6 to plus 3. Yes, Ragul, Bhuvnashri. Tell me, is it oxidation or reduction? Plus 6 to plus 3. Plus 6 to plus 3. Is it oxidation or reduction? Yeah? Plus 6 to plus 3. Is it oxidation or reduction? What did you eat today, Sarjana? Did not had your lunch properly? Prashanti, plus 6 to plus 3. Is it oxidation or reduction? See, if you ever get confused now in oxidation and reduction, what is oxidation? Oxidation means loss of electron, correct? Reduction means gain of electron. So if you ever get confused, I'll tell you an easy way out. Okay, so we have plus 6, we have plus 3. Okay, so one thing you remember, in any reaction, in any stable reaction, both of sides should be balanced. Both of the sides should be neutral, 0, 0, or it should have same charge. It should have same charge. Now, you have to balance that charge, Prashanti, Sarjana, you have to balance that charge using electrons. Okay, you have to balance that charge using electrons. So over here, I have plus 3. Over here, I have plus 6. So electrons means what? 1 electron is minus 1. So how can I balance it? I'll add 3 electrons over here. So since I added 3 electrons, plus 3, balance. Okay. So 3 electron on the reactant side. That means what? That those electrons are getting added. Those are not getting removed. Those are getting added. If the electron is on the product side, that means they are being donated. They are being given away. Over here, they are being added. So if something electrons are getting added to your element or atom, what do we call it? We call it as reduction. We call it as reduction and not oxidation. Is it clear, Prashanti? Yeah, we call it as reduction. Sajna, is it clear? Yeah. So that's why over here, your K2Cr2O7 is getting reduced. And who is responsible for that? Your SO2 is responsible for that. And that is why we just proved that SO2 is your reducing agent. Why? Because it is reducing your chromium to +6 to +3. Is it clear? Come on, give me yes in the chat box. Is it clear? Okay. So all of this reaction, whatever you see over here, all of this reaction proves that your sulfur dioxide, that SO2, is a reducing agent. Similarly, bleaching. Okay. Now tell me honestly, how many of you have ever, especially girls, tried coloring your hair? Anyone tried coloring your hair? Yeah. Anyone? Bhuvaneshwar says no. Prashanti, blue, purple, violet. Yeah. Yes. Sajna. No. Never did purple. Never did green. You know, there was a TikTok trend. All of them were going bizarre color. Yeah. Okay. They were giving the bizarre color to their hair. Yeah. Okay. So this bleaching. Okay. What is this bleaching? Okay. What is this bleaching? Bleaching means, okay, why did I ask you that color the hair? Because in that process also we use the process of bleaching. What do we do? You know, like you only imagine, Prashanti, imagine yourself with a head full of red hair. Okay, you want to make a red hair. Okay, you want to make a red hair. Now you have gone to a parlor or salon. Okay, Prashanti, do not open the next tab. You have gone to the parlor or salon and you tell him, I want to make my hair completely red. I want to look like a princess. Okay, I want to look like a princess, make my head completely red. Or I want to look like a Barbie, make my hair complete pink. No, Barbie's hair is blonde, I guess. It is golden, yeah. So make my hair completely golden. Now your hair is already black. Okay. Now I want to make your hair red. So if I apply the red color on your hair, will it turn into red? No, why? Because your hair color is already black. Correct? What result your color, what the resulting color will be what? Black plus red, whatever color you will get, that will be a resulting color. So what do they do, you know? They use this bleaching process, but not the SO2 one. I'm just giving you example. They bleach the hair. They strip down your whole, first they apply one cream. Okay. They strip down your whole natural black color, what you have on the hair. They make your hair white. And on top of that, then they will apply the red. Because on the white, they can apply red. On the black, they cannot, because you will get the combination color, not the red color. Are you getting it? Yeah. So do not color your hair. It is not good. Okay. I am the right person to guide you regarding hair. Okay. As regarding chemistry, I am the right person to guide you regarding hair care also. So do not color your hair. It is not good. Okay. So same is the bleaching process over here. Same is the bleaching process over here. What happens, you know, why that color, whenever you bleach, why does a color goes away? This we use for cloth and everything. Okay. And bleaching by SO2 is temporary process, while chlorine, we will learn in the halogens, it is a permanent process. Why? I'll explain you. So over here what happens, you know, this coloring matter. Now the color of our blood. Okay, the color of our blood, I hope it is red. No one is blue color blood. Yeah, purple, orange, pink. Yeah, we do not have choice. Our color of the blood is red. Yeah. So why do we have a red color blood? Who is responsible for that red color? Prashanti, is it because we eat too much of tomato ketchup? Yeah, is that the reason? No, na? Yeah, my bio people, come on, tell me who is correct. Prashanti, who is responsible? Yeah, correct. Sajna, Kirtini, who is responsible for the red color of the blood? Bhuvaneshwar, I know you like too much of French fries. Yeah, you dip complete French fries into a tomato ketchup. Yeah, isn't it? Hmm. So is that tomato ketchup responsible? No, the hemoglobin is responsible. So what is hemoglobin? Yeah, what is hemoglobin? Anything that imparts color, anything that imparts color on something, we call it as pigment. Okay, so hemoglobin is a pigment for blood. It is giving red color to the blood. It is a pigment. So what happens? This sulfur dioxide or this bleaching process, okay, it reacts with the pigment. Okay, so it reacts with the pigment. So pigment will react with sulfur dioxide. Sulfur dioxide will reduce that pigment and it will become colorless. It will become colorless. Okay, it will become colorless. Now why we are calling it as a temporary process? Because as soon as this we may use for cloth, as soon as we again we again introduce it to the oxygen or oxidation or even atmosphere, the color starts fading. Okay, it again starts converting into colored matter. Okay, again some color comes on it, and that's why we call it as temporary process. But this step does not happen in chlorine. In chlorine it is permanently color gone. Is it clear till over here, everyone? Yeah, is it clear? Come on, give me yes or no. Bhuvaneshri, is it clear? Kirtini, is it clear? Okay, so do not color your hair. Okay, not good for your hair. Chalo. Let us go ahead after this. Sulfur dioxide uses, okay, just now we studied for bleaching wool and silk. Okay, so that means coloring. Yeah, wool cloth, what we have, wool. Yeah, that is not color. Like, do we have, from where do we get wool, everyone? From where do we get wool? Who gives us wool? Yeah, who gives us wool? Sajna. Do not say the market guy. Yeah, we go and ask for wool, he gives us the wool from the market. Yeah, imagine the market guy has wool all on his body and you use his wool. From where do we get wool? Sajna, where do we get wool? Who gives us wool? Ragul? Punashri? Who gives us wool? Ah, yes, correct, Ragul. Very good. Finally, Ragul has answered something. Ragul is becoming active in the class. Very good. Hmm? So, sheep is the one who gives us the wool. Correct? So, do we have, like, if I want a red color sweater of wool, okay, if I want red color wool sweater, so I'll find a red color sheep and I'll make him bald. Is it so? Yeah. Will I find red color sheep and I'll uh, remove all his hair? Okay. I want a purple. I want a purple jacket. I want a purple sweater. So I'll find a purple color sheep and I'll bald him. I'll turn him, all the hair are gone. No, na? So bleaching. So we color. We take the wool in a white color only. We bleach that wool again with the colored matter. Okay. So for bleaching of wool, silk, it is used as a disinfecticide, germicide. Yeah, for this is there in every uses for manufacturing of important chemical. Obviously, that's why you are a chemical. This is your job. Yeah. Then liquid sulfur dioxide is also acting as a inorganic solvent. It also acts as a preservative. It also acts as a refrigerant. Okay, some of the uses not that important. Now, how many of you remember oxo-acids of phosphorus? Anyone? Yeah, raise hand. We did oxo-acids of phosphorus. Yeah, isn't it, Prashanti? So, oxo-acids of phosphorus. For example, H3PO3. Now, just like we have HCl, which gives us 1H plus, just like H2SO4, it gives us 2H plus. How many H plus is given by H3PO3, Prashanti? Yes, Arjuna. How many H plus is given by H3PO3, Kirtini, Bhuvaneshri? How many H plus is given by H3PO3? Yeah. How many H plus? Bhuvaneshri is 3, Prashanti says 3H plus. Yes, how many H plus, Arjuna? Kirtini, how many H plus? Yeah, how many H plus we will get? If answer was so straightforward, I will not ask you such question, isn't it? That shows you have not revised. That shows you have not revised. Yeah. Last to last lecture only we did it. H3PO3, I made you understand how to draw the structure. You forgot. Yeah. What we will do first, we had done this in detail. I'll draw P. Okay, I have H3PO3. H3PO3. I'll draw double bond O. Then remaining O. How many O are remaining? 2 O. 1, 2. Then I'll give the hydrogen. H. 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 If you remember the pH, Prashanti, it is non-ionizable. The pH bond is non-ionizable. Okay. But your OH bond is ionizable due to electronegativity. The OH bond is ionizable. Okay. This bond is ionizable. That's why it gives you 2H plus. Prashanti, not none. It gives you 2H plus. Sajna, is it clear? Bhuvanashri, Ragul, Gopinath, Kirtini, is it clear? Yeah, it will give you 2H plus. Okay, similarly, we have the structures for oxo-acids. Okay, we have the structures for oxo-acids important. For example, if I have H2SO3, come on, tell me. I have explained you how to calculate the oxidation state. Ragul, Kirtini, come on, calculate for sulfur. What will be the oxidation state of sulfur over here? Yeah, what will be the oxidation state of sulfur? What is the oxidation state of sulfur? Very good, Bhuvaneshri. Yes, everyone, what is the oxidation state of sulfur? Sarjna, Prashanti, Kirtini. What is the oxidation state of sulfur in H2S2O3? H2SO3, that is a sulfurous acid. You have to remember this, important. H2SO3. Yeah, H2SO3. Yes, Prashanti, what will be the oxidation state? Kirtini, what will be the oxidation state? Hmm. It is plus 4. Kirtini, do you know how to calculate or should I help? Please ask me. If you do not ask me, I will not able to help you. Please ask me. If you do not know, say I do not know, I'll help you know. If how will you understand if you do not ask me? Yeah. So H2SO3, I'll consider S as X. Rakul, I'll consider S as X. Correct? So this is X. What is the charge on hydrogen? The charge on hydrogen is generally plus 1. How many H we have? We have 2H. So 2 plus X. Oxygen charge is minus 2. 3 into minus 2, minus 6 is equal to 0. So X minus 6 goes that side, plus 6 minus 2, X is plus 4. X is plus 4. So the oxidation state is plus 4. Okay. Now look at the structure. The structure is like this. S, double bond O, OH, OH, H2SO3, H2SO3. Similarly, we have sulfuric acid. Okay, sulfuric acid is called as king of acid. Okay, sulfuric acid. I hope you know king of chemical, not only acid. Write it down. Sulfuric acid is called as king of chemical. He is the king of chemical. Yeah. So H2SO4 structure is like this. S double bond O, double bond O, OH, OH. That is our H2SO4. H2SO4. Then you have thiosulfuric acid. Come on, draw the structure. I want you to draw this. Important. Thiosulfuric acid. Thio means what? You have an extra sulfur. Okay. We use the thia word for sulfur. So thiosulfuric acid is again the same thing. Okay, but we have double bond S now. Then you have dithionous. That means you have two sulfur atoms. Come on, draw it. Everyone, come on, draw in the chat. Draw in your book and sit down in the chat box. Come on, draw it in your book and done in the chat box. Bhuvaneshwari is done. One, important structures are important. See what type of question will come from this. What type of questions will come from this? They'll ask you how many S double bond O you have, how many OH bond you have, how many SO bond you have. Such questions can come. Okay, such questions can come in the exam. Come on, draw it and done in the chat box. Sarjana is done, Bhuvaneshwari is done, Prashanti. You're not drawing it, draw it hard. Yeah. Important. Remember the name also. Okay, H2SO4 is sulfuric acid. If I remove one O, it becomes sulfurous acid. Okay, if I add extra S, it becomes thiosulfuric acid. Yeah, and if I add one more O to this, it will become dithionous acid. Okay, remember it like this. What I have done, I have added extra S to this, so it has become thiosulfuric acid. Extra S to this, it has become dithionous acid. Okay. The next we have is the polythionic acid. Again, sulfur role is there. Polythionic acid. Polythionic acid. So polythia. Thia again means what? Prashanti? Thia means sulfur. So I have polythia. So polythionic acid. Okay. Then we have disulfuric acid. We have disulfuric acid, or we also call it as a pyrosulfuric acid. Okay. This should be double bond O. This is the single bond OH. Okay. Then what do we have? Peroxo monosulfuric acid. Peroxo. Yes, peroxo monosulfuric acid. Peroxo. What is peroxo? Yeah. What is peroxide? What is peroxide linkage? Prashanti? This should be single bond, not the double bond. What is peroxide? Sarjana, Prashanti, Kirtini, Ragul, tell me. Bhuvaneshwari, Gopinath. What is a peroxide? Yeah. What is peroxide? 5 oxygen. Is it? Hydrogen peroxide. Prashanti. Hydrogen peroxide has 5 oxygen. What is a peroxide linkage? What is a peroxide linkage? Rajna, what is peroxide linkage? OH-OH linkage. Is it? So do we have OH-OH linkage in your peroxo monosulfuric acid? Correct, Bhuvaneshwari. It is not OH-OH linkage. It is OO linkage. Okay, it is OO linkage. This OO bond, whenever we have Prashanti, OO bond, no, we call it as what? Peroxy bond. Yes, this look like a face, but it isn't. This is a peroxy bond. This is a peroxy bond. Okay. So similarly, that is why over here I am calling it as peroxo monosulfuric. Why? Because I have OH, O, S double bond O, double bond O, OH. This bond or this bond is your peroxy bond. This bond is your peroxy bond. That's why I am calling it as peroxo monosulfuric acid. Peroxo monosulfuric acid. Okay. Peroxo monosulfuric acid. Now similarly, it should be a single bond over here, double bond over here, single bond over here, double bond over here. Messed up little bit with the bonds, but it's okay. Understandable. Okay. So similarly, again peroxo. Why peroxo, Prashanti? Because this is your oxide linkage. Peroxide linkage, not oxide. Your peroxy linkage. This is your peroxy linkage. Come on, draw the structures. Important, mark it important. Structures can come. Oxidation state definitely can come in the exam. Okay. And they will not give you the, it is very easy if they give you H2S2O7, or it is very easy if they give you the structure. No, they will ask you like tell us how many S double bond O is present in pyrosulfuric acid. This is what they will ask. They know you do not remember the name. Yeah, that's why they will ask how many S double bond O are present in pyrosulfuric acid. I just give you the example. Okay, that does not mean I am a paper setter. So if do not curse me in the exam, sir had told me that pyrosulfuric acid structure will come, but it has not come. Okay, it is a possible question. It is a possible question. Come on, write it down, write down the structures and tell me done in the chat box. Write down the structures and tell me done in the chat box. Bhuvneshri is done. So Archana is also done. Come on, Prashanti, write it down. Ragul, Gopinath, Kirtini, write it down and tell me done in the chat box. Okay, Prashanti is also done. Shalom. Let us go ahead. Let us go ahead. Okay. Now these are the structure. We have already done it. Okay. Now let us go to the king of chemical. What did I tell you? Who is the king of chemical, everyone? Who is the king of chemical? Yeah. Who is the king of chemical? Yes. Who is the king of chemical? Huh? I've told you now only, no? Who is the king of chemical? Correct. Sadhana, correct. Prashanti. Kirtini, who is king of chemicals? That is H2SO4, that is a sulfuric acid. And who is king at home? Prashanti, Sadhana. Is it you? Is it mom? Is it dad? Is it your brother? Is it your sister? Yeah. Achha, dad is the king. Like king means I am asking whose everything is like, whatever he or she will say will be accepted. Who is king at home? Sajna, it looks like you are the king at home. Yeah. Achha, brother. Okay. Shalom. Yes, Bhuvneshri, who is king at home? Do not give me a dialogue. No, sir, I am not a king. I am a queen. Yeah. Okay. Chalo. Let us go ahead. Yeah, these were the structures. So, king of chemical preparation. How do we prepare king? Yeah. How do we prepare king? How do we prepare H2SO4? How do we prepare H2SO4? Simple. Very simple. Okay, we have studied it. Yeah. So for we have sulfur. Understand this. You have to connect it like this. Sulfur. Okay. We have sulfur. We take the sulfur from any ore or something. Okay. That sulfur we oxidize it. I am just giving you a rough framework. Okay, rough framework I am giving. So we take sulfur. We oxidize that sulfur into sulfur dioxide. We continue the oxidation. We convert it into sulfur trioxide. I'll continue the oxidation. I'll convert it into sulfur trioxide. Then I'll use little bit of pure H2SO4. That pure H2SO4 will absorb sulfur trioxide. Okay, that sulfur trioxide will be absorbed by H2SO4. It will convert it into oleum. Okay, it will convert it into oleum. This is how we prepare it in the large scale. Okay, still it is used. And finally, we decompose that or we hydrolyze it, and what do we get? We get the sulfuric acid. We get the sulfuric acid. Okay, we get the sulfuric acid. Okay, is it clear, everyone? We get the sulfuric acid. Okay. So this is how simple. Okay, very simple. See, Preparation of SO2. First thing is we prepare SO2. From where do we prepare SO2? Generally, we prepare it from the ore. Yes, I hope we have understood the metallurgy chapter very well. Yeah. So iron pyrite is the ore of Fe. Correct. So from that when we oxidize the iron pyrite, presently what happens? Oxygen replaces the sulfur and your sulfur dioxide comes out. That sulfur dioxide, we oxidize it using the catalyst into sulfur trioxide. That sulfur trioxide is absorbed in the sulfuric acid, converted into oleum, and then we decompose it to the sulfuric acid. Then we decompose it to the sulfuric acid, the pure sulfuric acid. Now you will ask me why we are using sulfuric acid over here also. So it is just to get a pure grade of sulfuric acid. Okay, the final product should be pure. That's why we use the H2SO4 from that. Okay. So write down this. Come on, important steps. Preparation. This is how we prepare sulfuric acid, the king of chemicals. The king of chemicals. This is how we prepare the king of chemicals. Write it down and done in the chat box. And it is with water. Okay, it is H2O. H2O. Dilution with the water. Okay, hydrolyze it. H2O. Bhuvaneshwari is done. Come on, go ahead, everyone. Write it down. What is oleum? Okay, write it down first. I'll explain you. See, oleum is nothing but a fuming sulfuric acid. Okay, oleum is just a fuming sulfuric acid. It is extra concentrated sulfuric acid. Okay, from that we get our pure sulfuric acid. Okay, oleum is just a way. It is like a sulfuric acid only. It is just a fuming sulfuric acid. We hydrolyze that to get our sulfuric acid. Sure. Let us go ahead. Yeah, everyone. Okay. So this is how, see, we did 4 reaction, but this is the whole process. Yeah, you do not have to draw the structure anywhere, but look, this is how on the large scale we prepare H2SO4. I guess I've told you the story of H2SO4. Yeah, from my college time, there was a person. Okay, like, have you ever seen the glass soda bottles, the Pepsi bottles, what we have? Correct. It has a cap on the top of it. Generally it is made up of not aluminum, but it is made up of steel or something. Yeah, the cap. Okay. So whenever you have H2SO4, no, H2SO4 is also in a bottle like this. Okay, a huge bottle of 10 liters, 5 liters, a glass bottle, and it is brown colored bottle. Okay. On top of it, there is a cap, that steel cap you have. On top of it, there is a plastic cap. Okay, and just inside it there is a rubber, or I do not know the exact material, just like what we have in medicines. No, we open it from inside, such cap is present. Okay, such cap is present generally. Okay, so what do? We open this plastic cap. We do not do it. Is the skilled person in the laboratories. Okay, those working people, they do it. What do you call it? The person who help you with the chemicals and all those. You would be having a pet name for it. Yeah, I definitely know. What is the pet name for it in the south? What do you call it? The person who gives you the salt for analysis, the chemicals, who cleans everything. What do you call him? Yeah, Prashanti, Sarjana, come on, tell me honestly. Bhuvaneshri, what do you call it? Yeah, must be some South name or something. Come on, tell me honestly. No, we used to call them as mama. Mama means basically uncle, but a slang term for it. Okay, so what happens is that person was using this H2SO4, a pure 98% H2SO4. Okay, so what did he do? He opened the plastic cap. Okay, with the opener he opened this cap also, but now there is a cap inside this also. There is a cap inside this also. Okay, so he tried to open it. He tried to open it, but it was not getting opened. Okay, so what he did, with all his force, he put something over here in the corner. Again, with all his force, he pulled it. Okay, now obviously it is a concentrated acid, so some of the acid was over here also on the knob of it. Yeah, so just he removed it, and the droplets was all on his face. Okay, few droplets, 8 to 10 droplets directly splashed on his face. Okay, and obviously what will be your first reaction if something, I hope it does not ever happen, it will not happen, but if it in case happens, what we will do, the first thing, Prashanti, yeah, if some droplets from your lab, okay, goes on your face, what will you do? First thing, he did the same thing. What will you do? Do not say I will cry, sir. Yeah, that is the second thing. But what will you do if such incidents happen with us? Yeah, Sajna, Ragul, Kirtini, what we will do? What you will do if some droplets of acid splash more water? Correct? That is what we do generally. Yeah. Yes, Prashanti, we will splash water. Exactly same thing we did. But remember this. Yeah. Running water, obviously. Remember this. Dissolution process. That means add, whenever you add water to it, to the sulfuric acid, it is highly exothermic. It is highly exothermic. As soon as he splashed water, okay, what happened? Fumes came out from his face and all his head. Okay, it was like all fumes were coming out, and after some time, all black spots, like it was there till at least year or a 2 year, all black spots on his face. Okay, so the conclusion is the H2SO4 is highly exothermic. If you react it with water, H2SO4, you have to handle it with care. Yeah, not only H2SO4, all the chemicals you have to handle it with the care, isn't it? What do we do in the lab? Okay, our work is done. Let us put everything in the basin. Imagine what would be happening wherever that thing is getting collected. So yeah. H2SO4, please write it down. This can come in the match the calling, that H2SO4, it is prepared using contact process. Yes, H2SO4 is prepared using contact process. Contact process. So H2SO4, we use it using contact process. So see what is happening. We have sulfur in the form of ore or something. We oxidize it with the air. So what do we have? We have the impure sulfur dioxide and oxygen. Okay, that goes through the purification process. We wash it. We purify all the dust, whatever we have in the dust precipitator. We wash it with water. Whatever excess you have will flow away. The impurities will go away. Yeah. Then finally, then H2SO4 is sprayed so that whatever moisture is there, it is absorbed, no moisture is left. So finally, what do you get? You get the pure dry SO2 and O2. Okay, that goes into catalytic converter. If you remember over here in the reaction, you have written SO2 plus O2. What do you require? You require V2O5 catalyst. That is a vanadium pentoxide. Okay, so that goes into vanadium pentoxide. Okay, then SO2 and O2 react presently, and what do you get? You get the sulfur trioxide. Then it goes sulfur trioxide. Where does it goes? It gets absorbed in H2SO4 as oleum. So yes, you have the H2SO4, there in the H2SO4, and you get the oleum, that is H2S2O7. And when you hydrolyze it, you will get H2SO4. Is it clear, everyone? Yes or no? Sorry. Is it clear? Okay. Plant we do not want. Okay. Now look over here. So H2SO4, if we heat it strongly in the absence of oxygen or something, what will happen? Simply, whenever you heat something, H2O, that is dehydration, will occur. So if I remove H2O, what is left? Then SO3 plus H2O. Correct? And we all know H2SO4 is a strong acid. Correct? So H2SO4 is a strong acid. So the Ka, that is, it is very, very acidic. But HSO4 is not that much strong. The HSO4 minus is not that much strong. Okay. So its Ka is something like this. Little bit small. Not as large as H2SO4. Okay. Okay. Sure. Let us take a break. After the break, let us do this reactions. I require some time. Okay. So what is the time now? 7:59. So you have to back by 8:08. Okay. Sharp. Please do not come late. We have to solve so many questions, so many reactions. Theoretical chapter. Let us finish quickly. Okay. Please come back on time. Yes. Are we back, everyone? Come on, back in the chat box. Are we back? Come on, back in the chat box. Prashant is back. Come on, turn on your cameras. Bhuvnashri, are we back? Kirtini, are we back? Ragul. let us continue. Yeah, let us continue now. H2SO4, just now we discussed, it is an acid. So whenever Sarjana presents the acid and base reacts, what do we call it? Yeah, what do we call it? What type of reaction is it? Acid plus base is what type of reaction? What type of reaction is this? Yeah, what type of reaction is this? Acid plus base. What type of reaction? What do we call it? Decomposition, hydrolysis, substitution. It is, or anything related with neutral. Acid plus base. What kind of reaction is it? What do we call it? We call it as a neutralization reaction. Correct? We call it as a neutralization reaction. So acid plus base gives you salt and water. So salt and water. So base, acid, you have NaOH is a base plus acid react to give you salt, that is sodium bisulfate, and a water. Okay, sodium bisulfate. If you further further acidify it, it will give you sodium sulfate and water. Now, tell me one thing. How many of you have ever tasted ENO? At least have heard about it. Raise hand. Anyone? No, you have not heard about ENO. ENO, you see that ad, no. Yeah. When do we take? Yes, Prashanti, have you heard about ENO? Have you ever tried it? Not tried, but heard. Have you seen? Yeah. So what happens when you take ENO? And first of all, Kirtini, Ragul, when do we take ENO? Bhuvaneshri, when do we take ENO? Yeah. When do we take ENO, Prashanti? When do we take ENO? When do we take ENO? Correct, Sarjana? When do we take ENO? Prashanti? When we have indigestion. Not exactly indigestion, it is basically acidity. Okay, whenever you have excess of acid, no. Excess of acid being generated in your stomach. Okay, at that time we take ENO. Now ENO, after you take ENO, in 6 seconds, what do we get? Immediately, what do we get? What do we get? Sarjana, what happens immediately after 6 seconds when we take ENO? Yeah? We tell it to the whole society. We have taken ENO. How? We burp it. Oh, yeah? How our parents and grandparents burp. Yeah? We try to control it, but grandparents do not have any filter. Our parents do not have any filter on burp. Yeah? It is like the loudest ever thing you will hear, isn't it? Yeah? Loudest ever thing you will hear. Oh. And we are like, huh? What kind of sound effect is this? Isn't it? Yeah, what kind of sound effect? We burp like and our parents, grandparents, they do not have filter. Yeah. So burp, why do we have that burp? Why there is a burp instantly? Prashanti, Sajna. Why there is an instant burp? Ragul, Kirtini. Why do we have a burp? Why do we burp? Yeah, what happens inside our stomach so that we are like, okay, I have to burp. I cannot control. No matter how much you control, you press your mouth, you do whatever you want, you will burp. Why? Why? Yeah, Prashanti, why? See, in your ENO, you have carbonates and bicarbonates. Okay, you have carbonates and bicarbonate. Now look at this reaction. Look at this reaction. Your sodium carbonate, sodium bicarbonate. It is due to the come on. Yes, obviously it is due to the reaction happening in the stomach. Obviously, but who is responsible out of that reaction? See, this gas. Yeah, whenever ENO goes inside our stomach, the acid, it neutralizes it, and since it is a carbonate and bicarbonate presently, it releases carbon dioxide gas. Now carbon dioxide gas, it requires some outlet. Yeah, it requires some outlet to go out. Thankfully it comes, the outlet is our mouth. Yeah. So it comes out via our mouth and we burp out very loudly because due to the CO2 gas. Is it clear, Kirtini? Yeah. Due to the CO2 gas comes out. So that is the reason we burp. Okay. So remember, whenever you react sodium carbonate, sodium bicarbonate, those are also like your base. When you react with acid, you get salt, water, but also along with that carbon dioxide. Is it clear, everyone? Is it clear? Yeah. Okay. Similarly, if I reacted with calcium, it is very easy. Calcium is positive, oxygen is negative. So calcium sulfate and water. Ammonia. Ammonia, is it an acid or base, everyone? Ammonia, is it an acid or base? It is a base, correct. And why do we call it a base? Prashanti, Sarjana, why do we call NH3 as a base? Yeah, it is a Lewis base. What is a Lewis base? Lewis base means, yes, Prashanti, why do we call it as a Lewis base? Kirtini, Bhuvanashri, Ragul, why do we call it as a Lewis base? Because it donates the electron. It donates the electron. It donates the electron. That's why we call it as a Lewis base. So that's why again base and acid react to give you salt, that is ammonium sulfate. Ammonium sulfate. Okay. Similarly, if you react it with metal, again the same thing. Prashanti, zinc, magnesium is a metal. What you will get? Zinc sulfate, magnesium sulfate. Remaining H2 will be given out. If I react with oxide, you can see over here, if I react with oxide, I have oxygen, that's why I got water. Now I am only reacting with metal. There is no oxygen. That's why I do not have oxygen over here. I have the hydrogen gas. Is it clear? Prashanti, Sajna, Kirtini, is it clear? Purnashri? Yeah? Okay. Now this is very important for organic chemistry. Okay, very important for organic chemistry. For example, HCOOH. What is the IUPAC name for this? Come on, my organic chemistry people. What is the IUPAC name for HCOOH? Do not say formic acid. Formic acid is your common name. Formic acid is your common name. It is not an IUPAC name. What will be the IUPAC name? Yeah. What will be the IUPAC name for HCOOH? Prashanti, Sajna, Ragul, Kirtini. What will be the IUPAC name? Come on. What will be the IUPAC name? Yeah, what will be the IUPAC name? Bhuvaneshwari already told you formic acid is a common name, not an IUPAC name. It is a common name. It is not an IUPAC name. Okay. How many carbon are there? One carbon compound. What do we call it? Prashanti, Sajna, Bhuvaneshwari. One carbon compound. What do we call it? Yeah? Okay, Prashanti. One carbon compound. Meth. Correct? That is a methane. So meth, and you have the oic acid. Correct? So it is methane oic acid. It is methane oic acid. Clear? So as I told you, H2SO4 is a dehydrating agent. Dehydration means what? What happens when we dehydrate? That means loss of water. We drink water, correct? Because dehydration means loss of water. So whenever, look over here, dehydration occur, what will happen? OH and H goes away. What is left behind? The CO is left behind. That's why you have got carbon monoxide and H2O. Is it clear, everyone? Yeah, it acts as a dehydrating agent. Okay. Similarly, we have the oxalic acid over here, COOH, COOH. Yeah, COOH. So many O, no, COOH. Okay, so again, if I react, it is a dehydrating agent. So HOH is gone. What is left? Your CO, carbon monoxide, and carbon dioxide. Come on, write down these two reactions. It acts as a dehydrating agent. It acts as a dehydrating agent. Come on, write down both the reaction and done in the chat box. Acts as a dehydrating agent. Acts as a dehydrating agent. Acts as a dehydrating agent. Come on, write down and done in the chat box. Sarjana is done. Prashant, come on, write down and done in the chat box. Chemistry is done. Kirtan is also done. Okay, sure. What do we have next after this? Action with ethyl alcohol. Again, the same thing, everyone. C2H5OH means what? CH3, CH2OH. Again, the same thing. If I put H2SO4, Sajna, Prashanti, it is a dehydrating agent. That means what? H2, I'll write it like this. Look over here. CH3, I'll write it like this. CH2H, correct? So it will go away like this. So what did I get? CH2 double bond CH2, which is nothing but your ethene or ethylene gas. Ethene or ethylene gas. Okay. So CH2 double bond CH2, because your H2SO4 acts as a dehydrating agent. H2SO4 acts as a dehydrating agent. Okay. Similarly, copper sulfate, look over here. Copper sulfate hydrate. Again, I have put H2SO4. Again, what has happened? H2O will be removed because presently your H2SO4 absorbs that water and gives you anhydrous copper sulfate. Anhydrous copper sulfate. Is it clear? Presently, Sajna, is it clear? Okay. Come on, write down these two reaction and done in the chat box. Come on, write down the reaction and done in the chat box. Present Steve. Okay, now your H2SO4 we discussed, it is a strong oxidizing agent also. Yeah, H2SO4 is a strong oxidizing agent also. Yes, so H2SO4, for example, your H2SO4, what is the oxidation state over here? I want answer from everyone. Bhuvneshri, Ragul, Sajna, Prashanti, what is the oxidation state of sulfur over here? Yes, what is the oxidation state of sulfur over here? Correct? Prashanti, come on, calculate. Ragul, what is the oxidation state of sulfur over here? Come on, Prashanti, Kirtini, Ragul. Ragul, am I audible to you? Where did you go? Bhuvneshri, what is the oxidation state of sulfur in H2SO4? Correct? It is +6. It is +6. How did we calculate, Kirtini? H is +1. So 2 plus X, oxygen is -2. So 4 to the -8 is equal to 0. So X is equal to +6. Similarly, this is X is equal to +4. So +6 to +4, is it oxidation or is it reduction? Is it oxidation or reduction? Bhuvneshri, Kirtini. Is it oxidation or reduction? Prashanti, Sajna. +6 to +4. Is it oxidation or reduction? +6 to +4. Correct. +6 to +4 is nothing but reduction. And this proves that yes, Your H2SO4 is acting as an oxidizing agent, because what is oxidizing agent? It oxidizes the other substance. For example, your carbon has oxidized to carbon dioxide and itself undergoes reduction, that your H2SO4 sulfur from +6 it has gone to +2, that is nothing but reduction. So this just proves these reactions that yes, H2SO4 acts as a strong oxidizing agent. Is it clear, everyone? Yes, is it clear? So this is over here, just now we did it, H2SO4, SO2, 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 in every reaction. Wherever there is an elemental compound and if you react with H2SO4, okay, it will give you, it will act as an oxidizing agent. Clear, everyone? Yes, clear? So same thing over here, it oxidizes the metal also. For example, copper, if I react with H2SO4, what I am getting? I am getting copper sulfate. So copper sulfate means what? It is Cu plus 2. Correct? Cu plus 2. So Cu, yes, Cu is getting oxidized. Cu is getting oxidized. Yeah, Cu is getting oxidized. Correct? So yes, it is also acting as an oxidizing agent even for metals. Yeah. So give me SS in the chat box. Is it clear? Sure. Let us go ahead. No need to write down all the reaction. You have the PPT. You can look afterwards. Yeah, important reaction. I will tell it to write it down. Okay. Non-volatile. We are doing the chemical properties, by the way, of sulfuric acid. What do you mean by volatile? Yes, Prashanti, Sajna, Ragul, Kirtini. What do you mean by volatile? Organic chemistry or chemistry itself is volatile in nature, isn't it? Yeah. Chemistry itself is a volatile in nature, isn't it? Easily escapable. What? All the thieves are volatile, is it? Easily escapable. Is the escapable word correct? Volatile. Yeah? Volatile. Volatile. Yes, Prashanti? See, I'll give you one experiment to do at home. Okay. If you want chappals from your parents, correct, Kirtini? Okay, you can do that. Obviously, your mom would be having a good perfume, or your dad, or your brother, anyone from your home would be having a good, costly, you know, sweet smelling with a good fragrance perfume. Just open the bottle, okay, open the bottle and keep it overnight. Okay, open the bottle and keep it overnight and check tomorrow. With the bottle you'll receive the flying chappal. Okay, why? Because the perfume what you have, okay, will evaporate. That is a volatile nature. Easily it turns into vapor. Easily it turns into vapor. That is a volatile. So H2SO4 is a obviously non-volatile in nature. Precipitation reaction. Acha, your brother did that once. Did he receive the flying chappal? Okay. Precipitation reaction. So obviously if you react it with metals, we have seen copper sulfate, barium sulfate, it will form the precipitating agent. Lead sulfate, yes. Is it clear? Acha, he is elder. Okay, fine. Okay. Then this reaction we already know, sulfuric acid. If you absorb SO3 into it, what we will get? We get fluorine. We will get fluorine. Okay. Now structure of sulfuric acid. Now, why your sulfuric acid? Now this is also important. Why your sulfuric acid is a strong acid? Yeah, it has like some reason must be there. Yeah, why does he go to gym? Sulfuric acid goes to gym, that he is a strong. Yeah, no. There has to be some reason why it is a strong acid. Can anyone tell me why sulfuric acid is a strong acid, or what is a strong acid? What is a strong acid? Gives H plus easily. Perfect. Gives H plus easily. Now the question is, why it has to give H plus easily? Like, why? Why he's so desperate to give H plus? Why does it give H plus easily? I do not want it. Why you are giving it? Yeah. Why does it give H plus so easily? Yeah. Any reason? Like there has to be some reason, no? Like anyhow it will give you H plus so easily. Why would it give H plus easily? I agree. What is a strong acid? Strong acid is a substance that will give you H plus easily. Completely agree. But why? Why H plus? Why it will give H plus so easily? Yeah, there has to be some reason, isn't it? So the reason is, what is the structure of sulfuric acid? It is something like this, correct? Double bond O, OH, OH, correct? OH, OH. This is the structure. If I remove the H, what do I have? I have, I'll draw it like this, S double bond O, double bond O, O. Okay, if I remove it, I have O negative. Now this minus can go into resonance. This minus can go into resonance. So many resonating structure. Look over here, so many. Each of the double bond, each of the single bond, each of the negative sign can undergo resonance over here. Can undergo resonance over here. Are you getting it, everyone? That is the reason it gives away H plus easily, because it gives away H plus. It will form stable, yes, it will form stable resonating structures. That's why it gives away H plus easily. Clear, everyone? Yeah, is it clear? Come on, give me yes or no in the chat box. Is it clear? Okay. So uses of H2SO4, as I told you, always and always, chemical industry will always be there. Yeah, it is used as a drying and dehydrating agent. We have seen this. It is used in the storage batteries, lab reagent, always and always will be there in everything. In metallurgy, yes, it is used in metallurgy. Yeah, H2SO4, HNO3P mix, the two strong acids, it can even dissolve the strong hard metals. Correct? That's why it is used in metallurgy, fertilizing industry, petroleum refining, paints, pigments. We have seen that. Yeah, everywhere we use the H2SO. Is it clear till over here, everyone? Yeah. Okay, chalo. Let us go to the next PPT. Just a minute. Did I upload it? Just give me a minute. Today we have, like in the last lecture, I guess we did not do the class assessment. Yeah, we did not do it, no? We have to do that today. Go ahead to group 17. Group 17, yes. Group 17 are also called as what? Group 17 also called as, yeah. Group 17 also called as, yes, question C, Sarjana. Group 17 is also called as, they are also called as halogens. Yeah, group 17 are also called as halogens. You have fluorine, chlorine, bromine, iodine, astatine. Yeah, so remember till over here, fine. Fluorine, chlorine, bromine, iodine, astatine. Okay, those are your halogens. So now let us study about the halogens. Let us study about the halogens. Okay, for example, chloride. What is the main source of chloride? Where is this chloride? Where do we get it? Yeah, at our home. Chlorides. Do not say again the market guy. Yeah, chloride. We get it from NaCl. And NaCl, the salt. From where do we obtain salt? Why it is so cheap? From where do we obtain salt? Yes, question C. Rajna. From where do we obtain salt? From the chef. Yeah. From where do we get salt? Yes, Ragul. Gopinath, Kirtini. From where do we get salt? The salt that we have at home? From the sea. Correct? From the sea. Correct? From the sea water. Correct, Ragul. So we evaporate that, we purify that, and we get the salt. Okay, so sodium chloride. Okay, now highly reactive. Now tell me, like why it is highly reactive? There has to be some reason why it is highly reactive. Yeah, fluorine and all, why it is highly reactive? There has to be some reason, isn't it? Why it is highly reactive? Yeah, why it is highly reactive? Just because it wants to react, it will react. There has to be some reason. Yeah, why it is highly reactive? They are highly stable, so it will tend to give electron. If it is highly stable, it will not be highly reactive, isn't it? Stability inversely proportional to reactivity. Reason is wrong, assertion is correct. First time I am seeing this. Reason and assertion question. Sarjana has given one statement. They are highly stable. It will tend to give the electron. So the reason and assertion, first time I am seeing that assertion is wrong, reason is correct. Wow. Assertion is wrong, reason is correct. Yes, they will tend to give electron, but not because they are highly stable. They become stable after giving the electron. Okay, or you can say that F. Okay, what is the atomic number of fluorine? Prashansi, Sarjana, Kirtini, Ragul. What is the atomic number of fluorine? Come on, tell me. The atomic number of fluorine. Correct? It is nothing but Prashansi. Atomic number of fluorine. It is 9. What? You have to remember. Yeah? Fluorine is 9. I had given you almost complete one lecture, the first lecture of P-block to this. You have to remember. Fluorine is 9. Correct? So if I write down the electronic configuration, 2, 7. So in all of the halogens, the last valence electrons, 7. How many electrons does it require? It requires only 1 electron. That's why it is so reactive. That's why it is so reactive. It will not give the electron. It will take the electron. It will take the electron. Okay. That's why it is so reactive. Okay. Non-metallic, obviously, most of them are gases. Similarly, okay. Then your astatine and tennessine are the radioactive elements. Astatine and tennessine are the radioactive elements. Okay. Now abundance, we will study this. Okay, in the seawater and all those. Okay. Now look over here. Electronic configuration. I hope each and every one of you know how to write down the electronic configuration now. Yeah. I hope that. Yes. I hope each and every one of you know how to write down the electronic configuration. Yes, Prashansi, Raju, Kirtini. Yeah, we have done it, isn't it? If not, please watch our recordings. If you have not yet seen it, I have shared the trick how to remember the electronic configuration. Okay, it is very important. Then atomic radii. Yeah, what is the difference between atomic and ionic radii, everyone? What is the difference? What is atomic radii and what is ionic radii? Yeah. What do we mean by atomic radii? What do we mean by ionic radii? Yes. What do we mean by atomic radii and what do we mean by ionic radii? Yes, Kirtini, Sarjana. What do we mean by atomic? What do we mean by ionic? Prashansi, atomic radii, ionic radii. What is the difference? If you see, the difference is almost double. Oh my God. Ionic radii is the distance from the nucleus to outermost electron. Bhuvaneshri says. So Bhuvaneshri, what is then atomic radii? What is the atomic radii then? What is atomic radii then? Yeah. What is the atomic radii then? Are- okay. You have said the same thing. You have copy pasted the same thing. See, atomic radii means what? It is the radius of atom. If I have fluorine atom, that is 2, comma 7. Okay, so the distance from the nucleus to outermost electron. Correct. Now, ionic radii means what? It is the radii of ion. Ion, what is ion? Okay, so for example, sodium. Okay, sodium, the atomic number is 11. Correct. So 2, comma 8, comma 1 is a sodium. But ion is what? Is the closest stable configuration. How does it form? It gives away the electron. It becomes 2, comma 8. So the distance will be your ionic radii for 2, comma 8. Okay. When I say fluorine, to become stable, fluorine adds the electron. I will consider F minus. Are you getting it? Yeah. So this distance of F minus from the nucleus to the outermost electron, that is your ionic radius. So you can see over here F, F minus, Cl, Cl minus, Br, Br minus, I minus. And why there is so much of increase? Because due to increase of electron, due to add of electron, there is a repulsion. You are not adding a proton over here. You are adding only electron. And due to that, due to the repulsion of electron, the size increases by a large number. Are you getting it, everyone? Come on, give me yes or no. Is it clear? So as you go down the group, obviously atomic radii will also increase, ionic radii will also increase. But in the non-metals, always and always, ionic radii will be greater than the atomic. Okay, and in the metals it is opposite. For S block it is opposite because you remove one electron, so Na is greater than Na plus. Clear? Sure. Then ionization enthalpy. Enthalpy is nothing but energy. Ionization means tendency to remove one last electron. So obviously non-metals, they do not like to give away the electron, they like to take the electron. So the ionization enthalpy is very, very high. It is difficult to remove the electron. It is difficult to remove the electron. So if it is difficult, that means more energy is required. More energy is required. That means 1680, very large number, because fluorine is already small. The nucleus and outermost electron are close to each other. On top of that, it does not lose electron. It wants to take the electron. Hence, the value is such large. Okay. As you go down the group, obviously it will decrease due to increase in the size. Due to increase in the size, the value will decrease because you can easily give away the electron as the size increases. As the size increases. Is it clear, Rajna? Is it clear, Prashanti? Okay. Similarly, you have electron gain enthalpy, that is energy absorbed or energy which is evolved, yeah, given away or taken in during the addition of electron. That is electron gain enthalpy. You can see it is negative. When enthalpy is negative, what is the meaning of that? When the enthalpy is negative, Prashanti, Sadhana, when the enthalpy is negative, Ragul, Kirtini, Gopinath, when the enthalpy is negative, what is the meaning of that? What kind of reaction is that? Endothermic, exothermic, what is it? A hint. When the enthalpy is negative, is it exothermic or is it endothermic? Yeah. When the enthalpy is negative, is it exothermic or is it endothermic? Come on. It is exothermic. It is exothermic. Okay, that's why you can see whenever we add the electron, it is not easy to add. So all the electron gain enthalpy is exothermic. All the electron gain enthalpy is exothermic. So as you go down the group, it decreases. Only chlorine is the exception. Please write down the chlorine is the exception. Yeah, chlorine is greater than fluorine. Chlorine is greater than fluorine. Okay, then everything less than chlorine and fluorine. Come on, write this down. Electron gain enthalpy. Electron gain enthalpy. This is the exception. Please remember, these exceptions can come. Okay, electron gain enthalpy. Fluorine has the highest. See that negative charge, do not get confused. I know minus 349 is the smallest number in all of that. Okay, but that negative charge does not indicate the number. It indicates that the energy is released. Are you getting it? Yeah, 349 is still the highest. Okay, so electron gain enthalpy, chlorine is more than the fluorine. Right on the top, right in the bold, important, electron gain enthalpy. Done. Can we go ahead? Come on. Yes, in the chat box. Okay, electronegativity. We all know what do we mean by electronegativity. Electronegativity, Prashanti, Sarchna, come on, tell me. What do we mean by electronegativity? What do we mean by electronegativity? Yeah, what do we mean by electronegativity? Tendency to pull. Tendency to pull electron towards itself. Correct? So electronegative, the halogens are most electronegative elements in the periodic table, and fluorine is the most electronegative element. Most electronegative element in the periodic table, that is nothing but your fluorine. So fluorine is the most electronegative element. Okay. Now if I ask you HF, HCl, which is a stronger acid? HBr, HI, which will be the stronger acid? In HF, HCl, HBr, HI, not only HF and HCl. Which will be the stronger acid? Prashanti, Sajna, which will be the stronger acid? We know acid is the something that gives away the proton. So who will easily give away the proton? Prashanti, who will give easy proton? Sajna, you did mistake in this concept last time also. Who will easily give away the proton? HF, HCl, HBr or HI? Yeah. Who will give away easily proton? An exactly wrong answer was given by Sajna in the next previous class also, Sajna, which is the HI. Why? Forget about electronegativity. That's why I asked you this question. I know you will get confused. Look at the size. They are comparable. HF is comparable. HCl is like this. HBr is like this. HI is like this. Can it hold it? Can they hold together? Bhubaneswari, it is not HF. It is HI. Yeah, HI. Why? Because H will be lost easily due to the size. Remember, we did this in the last class also. Sarjana, exact same mistake you did in that also. You told us HF because of electronegativity. You know that F will take away the negative faster. So you thought that H will give away easily. No, it is the HI. Forget about the electronegativity. Look at the size, so small. Yeah, is it clear, Prashanti? Sarjana, is it clear? Bhubaneswari, is it clear? Okay. Now, as you go down the group, remember this: fluorine, chlorine, bromine, iodine. Iodine is a solid in nature. Fluorine and chlorine, they are the gases. Bromine is a liquid. Come on, write this down. Bromine is a liquid. Okay, as you go down the group, remember your state of matter goes from gases, liquid to solid. Okay, fluorine, chlorine are the gases. Bromine is liquid and iodine is a solid. Iodine is a solid. Iodine is solid. So fluorine and chlorine, since it is a gas, it reacts with water. Please remember, fluorine and chlorine, since it is a gas, it reacts with water. Bromine and iodine, they are soluble in water. They are soluble in water. Okay. Non-metallic character decreases down the group. Yes, obviously it is becoming solid, so it is going from non-metal to metallic character. Non-metal to metallic character. So non-metallic character decreases, metallic character increases down the group. It increases down the. Okay. Now anything, same trend, same property. Okay, we have discussed this. Let us go ahead. The color. As you go down the group, it becomes dark. Write down the color. Fluorine is light yellow. Write down Prasanthi, Sajna. Fluorine is light yellow. Write down Bhuvaneshwari. Chlorine is greenish yellow. Bromine is a reddish brown gas. Oh, sorry, reddish brown liquid. And iodine is a dark violet. Iodine is a dark violet. Okay, iodine is a dark violet. Write down and done in the chat box. Let's go ahead now. Oxidation states. Oxidation state. See, very interesting. Oxidation state. I know not so interesting. Okay. Okay, but still we have to do it. Okay, we will finish this chapter soon. It is already fifth lecture. Yeah, fifth lecture of this. So I guess 2 more lecture or probably 3 more lecture. Okay, then this will be finished. Okay, one lecture I have put only and only for the questions. Okay, one lecture is only and only for the questions. Okay, probably the last lecture before the chapter assessment. Don't worry, I know we have not done too many questions. In that, we will solve all of the PYQs of your NEET. Okay, and the expected questions also. But for that, you have to do this. You have to revise this. Yeah. Chalo. Oxidation state. Let us go to oxidation state. So we are going to deal of oxidation state other than the fluorine. Okay, other than fluorine, all of them we know it is NH2 NP5. Why we are not considering fluorine? Because due to the small size, it shows little bit of different properties. Okay, it shows the anomaly. Okay, it shows the anomaly. Okay, so we consider oxidation state apart from fluorine. Now NH2 NP5 ND, this is what VBT I have drawn. So what are the possible oxidation states? See, look over here. Sarjana, Prasanthi. One unpaired electron. It can take unpaired electron, can make a bond. It can give away the electron and can form a bond. That's why -1 or +1 is possibility. -1 or +1 is the possibility. Similarly, it can form bond with, it can go like this, can go over here, the unpaired electron. So it can take more 3 electron to become stable. So +3 oxidation state. Yeah, because it can have +3. It can give away the 3 electron also. Similarly, 5 unpaired electron. So +5 is also possible. +7 is also possible. +7 is also possible. For example, IF7 is there. Yeah, what will be the oxidation state of I over here? Yeah, what will be the oxidation state of I over here? It will be +7. Yeah, x -7 is equal to 0, x is equal to +7. Okay, so it can go up to +7. Come on, write it down. Possible oxidation state -1, +1, +3, +5, +7. Write it down. Come on, and done in the chat box. -1, +1, +3, +5, +7. Come on, write it down and done in the chat box. More 5-10 minutes, then I'll give you the assignment. Okay, take your time and do it nicely. Okay, so the oxidation state C. Fluorine can only go in the -1. It does not like to give away the electron. It will take the electron. Write it down, please. All of them. Okay, all of them, whatever you have written, your chlorine, bromine, iodine follows it. Okay, chlorine, bromine, iodine follows it. Fluorine is the exception. Due to the small size, it can only take one electron. It does not like to give away the electron. That's why it is -1. Clear? Why fluorine is the exception? Yes, this is clear, everyone. Okay. Now trends in the chemical reactivity. Reactivity. See, look over here. Always and always remember. As you go down the group, the reactivity decreases. As you go down the group, the reactivity decreases. Okay.